Hello everyone, my name is Kang and I'm doing this presentation as part of my cyber operations course with instructor Alex Hepp. In addition, there's a disclaimer that this presentation is solely for educational purposes only, and then I will not be liable for any damages that can be caused by this presentation or any of the demonstrations throughout this session. With that out of the way, this presentation is focusing on artificial intelligence within cybersecurity. However, with this topic being such a broad field of study, we're going to be focusing on a type of artificial intelligence known as machine learning. So just to quickly jump right into it here, we're going to be breaking it down into some parts here, right? So the first slide we're going to be looking at is what is artificial intelligence. We hear it all the time, but do we really know what it is? The importance of artificial intelligence. We're gonna jump to some real world cases of machine learning, common machine learning algorithms, machine learning methods, supervised, unsupervised, semi-supervised, and then reinforcement. And then we're going to look at some advantages and disadvantages of machine learning. And lastly, we're going to end it off with a demonstration. So first off, what is AI, right? Like with this day and age, this term is more common now, just because the evolution of technology has allowed us to kind of bring up artificial intelligence more often now. But AI is basically the technology of having a machine or system or a computer even to have the ability of stimulating or having the idea of having human intelligence or human problem solving capabilities. AI can monitor, analyze, detect, and respond to cyber threats in real time. So the 3 points that I have here is that they can prevent unauthorized access, prioritize risk, and its security automation. So just to dig in just a little bit deeper into those 3 points is that AI algorithms can scan massive amounts of data. So in turn, they can detect patterns, indicates if there are cyber threats, and then it can prevent unauthorized access, for example. And one of the also strong points of it is that it can scan large networks or an entire network even for weaknesses to even prevent common cyber attacks. Jumping to that next point, prioritizing risk, right? Like AI can help prioritize risk because it can instantly detect malware or intrusion before they even occur. And then jumping to that last point is security automation. AI can serve as an engine for security automation. By that I mean is that it can free up time and resources for employees, right? Just because you don't need an actual physical person and doing anything, AI is doing all that for you. In addition, it can also help prevent human error. And then, as I mentioned before, AI is such a broad field of study, so we're just going to narrow it down and then within this presentation. So we're just going to be focusing on machine learning. And then jumping to this next slide, right? Importance of AI. Why is it important to have AI within cybersecurity, right? AI systems can analyze, like I mentioned before, right? Like it can analyze large amounts of data to quickly identify like patterns and potential threats that could be that is typically missed by traditional methods, right? And then having the ability to do this in real time is crucial. Because sometimes having a human look over things or using these traditional methods, you can't always find the actual incident or malware or intrusion at the time. It takes time, but with the help of AI, it's more potential to find that and in real time. Second point is that it improves response time. So by that I mean like AI can automate responses to certain types of cyber incident depending on what it is. So it'll reduce the time between detection and mitigation. This rapid response helps limit the damage caused by cyber attacks, right? So the sooner you can detect this, or the sooner AI can detect it, the smaller the amount of the damage that it can do, right? And then next would be proactive defense. AI enables predictive analytics, which allow organizations to predict and anticipate and prepare for what type of attack will come because they kind of know what's coming already, right? Like it's kind of like the calm before the storm, if you think about it. But yeah, this will enhance the overall security and organization security. The fourth point is handling complexity, right? Like modern cyber threats are always gonna evolve and advance over time, all due to because of the advancement and the evolution of technology, right? As technology evolves, so will cyber threats. So, with the help of AI, it can integrate and analyze diverse data sources to predict newer attacks. Number five, reducing the workload for security teams. Right, like I mentioned, with it being an AI system, it's already stimulating the idea of having human intelligence and having the problem-solving capabilities that a normal human would. So this you wouldn't have to waste time, or you wouldn't have to waste a employee time or a resources on this at all. Um, but with this being automated system and um, professionals can focus more on like strategic activities to improve the overall efficiency and effectiveness of the organization. And the next point is number six, which would be scalability, right? AI can handle a large amount of volume of data. And with the increasing number of devices connected to networks and maintaining robust security in the face of the growing digital infrastructure, right? Like, so with it handling so much at once, a normal human, or I guess to say like an employee, wouldn't be able to handle all that as fast or as effective as a um, AI or a machine, right? And then last is that seventh point, which is adaptive learning, right? AI systems can continuously learn from new data that is put into it and also past incidents, right? So it stores everything and it kind of improves the ability. So it's proving their ability to detect and respond to threats over time. So this adaptive capability ensures that security measures evolve alongside with the evolving cyber threats. So pretty much overall, AI enhances the ability to protect just digital assets, right? Like by protecting digital assets, and so by doing so, it's providing faster, more accurate, and scalable solutions to combat this advancement or this evolution of cyber threats. Next up, what is machine learning, right? Machine learning is pretty much a subset of AI, right? Like it's the child of the parent of AI, or you can think of it as the apple and AI being the tree. Uh, but the main difference between AI and machine learning is that AI encompasses the idea that a machine or computer can mimic or can stimulate having human intelligence, while machine learning aims to teach a machine how to perform a specific task so it can provide the results for the desired outcome. AI is a type of machine or technology that uses data. It's data driven, so it everything is done with data, right? Like you have to put something into it for it to actually work. Um, so it can make predictions, can make results, things like that. So some of the applications that you typically use machine learning are speech recognition, fraud detection, automation tasks, and recommendation systems, right? So if we were to look at some real world cases, right? Some of these things we use from a day to day basis. Some of them not so much. But some of the one that you use more often are like social media, right? Like Facebook, Twitter, Instagram, any social media, right? Like it uses machine learning to analyze your likes, the comments, the messages, images, videos, audios, even. Because the algorithm classifies these features into specific categories using clustering, right? Clustering is just a method that we'll cover a little bit further down in this presentation. But it uses this method to categorize certain things into certain categories. So it can decide what to show the user, in this case, you, right? Same kind of idea with entertainment platforms, right? Like Netflix, Hulu, YouTube, even. So it analyzes the pattern of the different genres of movies or TV shows that a user watches. So by doing so, like for instance, Netflix can predict how likely a user will watch a certain genre or a certain movie or TV show based on your previous rating of a certain movie, or based on just what you've watched, right? And then next is that fraud detection, right? Like fraud detection kind of refers to banks, right? Banks use machine learning algorithms to kind of determine unusual patterns. So like whenever you see unusual patterns and activity, your bank will kind of shoot you a notification or even call you even saying, "Hey, did you do this transaction?" and things like that. And that's kind of where machine learning comes into play. And then next is speech to text. You might not use this so often, but speech to text is pretty much analyzing audio output and converting it into written text within real time, right? Like you don't have to wait very long for it. This is possible because the machine learning, it can recognize and interpret speech patterns and language model to transcribe the audio. For example, like your Apple speech to text, you use it on like the Apple text messages, right? Like if you go to your text messages, down at the very bottom right, there's like that microphone where you can speak into it and it'll convert everything into text right away. Um, and then lastly is facial recognition. This is what we're seeing more and more common now, because facial recognition, you might use it on your phone, right? Like if you use facial recognition on your phone, same exact idea as if you were to use it on like a laptop or your computer that uses facial recognition to sign into devices, right? This works because again, like machine learning is comparing and verifying your facial features to the patterns of what it has already of when you originally scan your face, right? Like it's storing that data and then it's pretty much comparing the current facial features of yours and comparing it to that, and if it matches or if it resembles that, then it unlocks that device. So now we're going to be looking at some common machine learning algorithms. So first off is that neural networks, right? Like this stimulates how a human brain works. So like with the huge number of link processing nodes, it's good at recognizing patterns, which makes them important in applications such as like language translation, image recognition, speech recognition, and even image creation. Next up is linear regression, right? Like it's used to predict it for this method or this algorithm. It's used to predict like numerical values based on the relationship between each of these different values. So, for example, like this technique can be used to predict like housing prices based on the historical data of that specific area. And then next up, jumping to that third point is logistic regression. This is a supervised learning algorithm, right? Um, it's a method that we'll cover just a little bit, but it makes predictions for yes and no answers to certain questions. It can be used for applications such as like classifying spam, like email spam, or quality control on a production line, right? And then here we're gonna cover clustering. Like I mentioned previously, clustering is pretty much in the algorithm that identify patterns in data so that it can group it and categorize it. Next would be decision trees. This is like a family tree, right? Like decision trees can be used for both predicting numerical values and also classifying data into categories. So it's kind of like the combination between clustering and also the idea of linear regression, right? Decision trees uses a branching sequence, so kind of like a tree, hence the name decision trees. But in doing so, it links the decision so that they can represent a tree diagram. And the next would be that random forest. In this last point, the machine learning algorithm in this point, the machine learning algorithm predicts a value or category by combining the results from several decision trees. So the random forests kind of fall hand in hand with your decision trees. Next, we're going to be covering the methods. So what type of methods is being used whenever machine learning is in progress, right? So supervised learning is the first one here, and the machine is taught by an example, right? So meaning that it only knows what's inputted into it. So when a user inputs a data set into the machine, the algorithm will find a method to arrive at what is considered as the user's desired outcome, because only the user knows what what's wanted or what's the desired outcome. Um, so by doing so, this algorithm kind of identifies the pattern, learns from the observation, and makes predictions. And in addition, like this machine, like this learning, um, the machine can make a prediction and is continuously corrected by the user until the algorithm is at its highest level of performance. Next is in a unsupervised machine learning, there is not a user, right? Everything is all based on looking at the patterns and the relationship between the two. And by doing so, like it uses the method of like CAD clustering or arranging it in a way to organize the data into categories. And then next would be semi-supervised learning. This is kind of like the sweet spot, or like the medium between supervised and unsupervised, because it uses both, right? Supervised using both labeled and unlabeled data sets to train the machine. When I say labeled data sets, it's just meaningful tags, so things that are important, things like that. And then when I say unlabeled data sets, it's things that are not as important. So it doesn't contain any additional information, which is more seen in like unsupervised learning, whereas labeled data sets are more seen in supervised learning. And then lastly is reinforcement learning. So this kind of runs on rewards and feedbacks that allows the machine to arrive at the desired outcome. So it uses a provided set of action parameters and end values to determine this. In short, this machine is kind of like a trial and error, right? Like it runs on past experience and begins to adapt its code or algorithm in order to come to the desired outcome, or whatever the user is trying to come to. And then next up, we're going to be looking at advantages, right, of machine learning. So it can easily identify patterns because it can review large data sets and identify and discover patterns that a human I wouldn't say wouldn't be able to, but at a faster rate, right? Like having a machine look over these large data set, you're going to be getting to be able to find those patterns and those malwares or intrusion much faster than a human would. And then next would be that no human intervention is needed. So when I say that, is that no human is required, since it's an automation, which means that the machine is doing all the work and the discovery. The machine makes prediction and improves on the algorithm itself. It doesn't need to be improvised, or doesn't need to be edited by a user at all. Next is, like I mentioned as well with that last point, is that it's continuous improvements. So like I mentioned before, doesn't need anyone to kind of help it at all. It does its own thing, kind of makes improvement based on the experience that it's gained, past incidents, things like that. And then next would be handling a large variety of data sets. So when I say that, is that it can handle large, so like the wide application and the variety of data sets kind of go hand in hand as well. Is because you can implement, or you can kind of put in data sets from like a healthcare industry or like a academic field as well into it, and it'll still be able to work as well. Everything is not you're not kind of stuck into one kind of category at all. So like you can't just use this on malware or things like that. You can use it for plenty of applications. Some of the disadvantages, right? Like it requires a large data set to be able to give you the best results and the best performance, because it should be inclusive and unbiased to get the best quality results. And then with that large data set, it also requires a lot of time and resources, right? So resources kind of goes with that large data set to be able to train on, and then time, right? This large data set will require some time in order to be able to go through everything. And then next would be interpretation, right? Interpretation is a challenge for machine learning because it can accurately because it accurately interprets the results the algorithm generates. And then lastly is errors, right? Machine learning will have errors. It's not perfect, but when a data set is not large enough, because the data set is, if it's too small, the results will become biased predictions. And as a result, the machine learning won't catch this error, and it'll just take much longer for it to recognize it, and then even much longer to kind of fix it. So now if we were to look at my demonstration here, so let's see. So what I'm kind of covering for this demonstration is password, right? The password, whenever you make a password for anything or any accounts, it always gives you a preset of passwords. So like on the side here, we're looking at some requirements that it's giving us, right? This is kind of what machine learning is, right? Like it's forcing you to kind of put in to be able to fit in that requirement. So if I were to just make a password here of something here, it'll give me, this is kind of like the back end of things, right? It's showing me the numbers of characters that are used, the numbers of uppercase letters, lowercase letter. If I were to punch in 1, 2, 3 here, gives me everything here now. And the coloring here also kind of helps as well. Like this website is very, very useful. I believe it's from the University of Illinois that made this website, right? Like it's extremely helpful whenever you're trying to learn on the back end of things. But this is a great example of machine learning, right? Like it's like it only knows what you put into it. Like it'll only know what you put in. But other than that, that is all that I have for machine learning. Hopefully this video was informative and was able to help you learn a little bit more about artificial intelligence and machine learning. But thank you guys for viewing my video, and you guys take care.